All right. Let's see. All right. I don't know if I brought any copies of that thing with me. Got one copy of that thing with me. Shit. So hopefully you got that. Yeah. You good?
I don't know, I have a question.
Yeah.
Did we finish the synthetic division chapter?
Yes.
So we're supposed to know it good? No?
Yes. But we can review it. Of course we can. Yeah. So let's do that first.
Okay.
Not me. Oh man. Not me. All right. So, for example, if I had to do this, oh shit, I'm such a litterer. If I had to do, there we go. So nice. See you guys get excited about each other. How do I set this up? Synthetic. Does anyone want to see long division?
No.
I love you guys.
Not really.
Not really? No.
So you have to put them in descending order, right?
Say again.
You have to put the exponents in descending
Beautiful.
order.
It's got to be in descending order for synthetic division to work. And for long division to work. Easier, at least. But if I go to set up synthetic, what do I put in the little penalty box?
3.
Sorry. I don't mean to so vehemently shake my head, but why is it -3? I told you why when we were setting it
Because
up.
x minus -3 is the same thing as x plus
True,
Because you
but
don't
really,
have to change the signs after.
yeah, so I'm dividing by x plus 3, and synthetic says forget about your variable, so there's a 3. But then I have to change the sign every damn time, so let me just change the sign once. I like it. So the quick way is what makes this 0, that's what goes in here. I like it.
Oh, yeah.
And what goes here?
1, 4,
Watch.
-5,
Beautiful. And then some people get lost on the first step. What kind of gets me started? Bring down this guy. Bring down the 1. That escalated quickly. And then don't circle this. This doesn't mean a damn thing. What's the answer? What did you start off with degree-wise?
x.
X cubed. So this is going to be 1x squared plus x minus 8. I like it. And that's equivalent to putting and something over something as the remainder. All right, we know the better way to write that is as a fraction. That's exactly the same thing that's going on there. Now watch. This is kind of cool. Here, real quick. Do this extreme review. Yeah, Jeff, yeah, way to sell that. Extreme review, just multiply it. Multiply that real quick. Good little review. From the homework, some of us need that review. Supposed to be over this way more? Yes. Let's point you this way a little bit. What's happening on Thursday, by the way?
Test.
That is not a Fool's. That's not an April Fool's. I know. Everything happening today, you're like,
What chapters are the tests?
huh?
What chapters?
Oh, I think we left matrices off the last test. So it starts with matrices and goes to chapter 6. Tomorrow we're going to know for sure how much of 6 will be on there. Depends on if we finish 6, it'll all be on there. But yeah, okay. I'll be like Sauron. Hobbits. All right. So what do we get when we multiply this? Are you guys, or was I distracting you too much?
Minus 6 plus 3x squared plus 3x.
So you get x cubed plus 4x squared minus 5x minus 24. X cubed plus 4x squared minus 5x. This is off by how much?
Negative 23.
By 23.
Oh, yeah.
Yeah, you can see that? Right? Maybe?
Sure.
This is how much off this times this is from being this. The same way, I mean, if I do, what's 49 divided by 6? Just trying to see. So you're thinking about it, or you're trying to guess what I was going to write? That's hilarious. 8 times 6. And on the way, you see that, 6 times 8 is 48, plus 1 is 49. And watch, you ready for some really weird shit? What does 8 and 1/6 mean? It doesn't mean 8 times 1/6. We know better than that. What does 8 and 1/6 mean? What operation is hidden? 8 and, yes. 48. What's 6 times 1/6? 48 plus 1 is? Yeah. So, I mean, that's why we write it like that, because that is the number that I multiply by 6. And you ready for this shit? Let me see if you guys are really ready for this shit. What is x plus 3 times all this? Well, it's this times this, which we did. Right? Did we do that first piece? I know, I'm freaking out. And then this times this is, bam, bam, 23. What's negative 24 plus 23? Freaking negative 1. Yeah, of course. Right? Whenever you divide something, it means that when you multiply what you get by what you divide it by, you're supposed to get the top. I don't care if it's got variables in it. I don't care if it's got numbers in it. It's just the way it works. You guys semi with me? Mm-hmm. Okay. All right. Now let's go back into factoring.
Can we do a question from homework?
Yeah, sure.
Okay, mine's from 5.9.
Oh, okay. So this one's got g of x. This is 5, 9, 20. I'll tell you at the beginning that g of x is, where do you go? 20, right? Yeah.
It's
X
G of
squared
F,
plus 2.
right?
Say again?
Is it G of F? Or?
Well, hold on. I'm just writing down what g and f are. And f of x is negative 3x plus 1. Let me ask you a couple things. I'm going to build up to your question, right?
Okay.
What would your gut tell you f plus g of x is? What would your gut tell you do to get that? We kind of talked about this real quick before. What do you do to get this? You take f and you take g and you add them. It's crazy. So this really means, f of x plus g of x. It's just another way to write it, f plus g at x, meaning leave the x's in, don't plug numbers in. Right? So then you would just add those two together, and you would get x squared minus 3x plus 3. That's amazing. So the question they're asking you, instead of this, is I think it's g over f, right?
It's division.
Yeah,
Yeah.
it's division. So how do you get this?
Divide. Divide. Should divide.
Yeah, you take G, and you put it on top of F. And then you're done. That's awesome. So it really does. If I saw this, what do you think I would do? Besides free. What's this mean? What operation?
Multiplication.
Yeah, so you just take F, multiply it by G. Then you have to distribute and do something. Here, there's not shit you have to do. Just leave it like that. You guys all right? No? Any more questions from homework stuff? Yes?
Consider 40. Same type.
Oh, okay. What's a better way, thinking about this, what's a better way to write this? I think that's what it says, right? No, it says 05. Oh, I see. That's the year. 05. So if this is a graph, and it's got years at the bottom, 2005, 2006, and it's got several things graphed. P was blah, blah. What is P? Where'd it go? Composting, recycling, and combustion with energy. Oh, boy. All these different ways to do stuff with trash. So a better way to write that is the same way you kind of break this up. All I need to do is figure out what P in 05 was. Add it to what R in 05 was. Add it to B in 05. Look at the graph, get this. Estimate it from the graph. Add it to this. Add it to this. Is that cool? Yes? No? Is that cool? I mean, thank God that's what it means. What does this mean? Well, it means take that here, add it to this here, add it to this here. That's exactly what that means. That's what you hope to God that meant.
Was the question just asking the best way to get that?
No, question is just asking what the hell is that?
Oh.
So now you got to go get the numbers from the graph and add them up, and you're done. It's estimation, so not everyone's going to get the exact same answer. If you get the exact answer the solution manual has, that gets me worried since it's estimation. So my smart cheaters know to change it a little bit. If you're good at cheat smart. Cheat smart. Nobody got that. Poor evil dad. Anything else from homework stuff or homework stuff? Okay, let's get back into factoring. Nobody knows that? Shop smart, shop smart.
I could do it.
You got it? Thank you. All right. That was like, I got it, just was stupid. All right. I opened myself up for that. So let's remember what we know about factoring so far. Factoring. Here's what we did last time. What do I look at for this guy? This is a nice one. There's not too many things it could be.
What multiplies to 30 and adds to them?
Beautiful. And why does it boil down to that? We did a couple of motivational ones to see it going forwards. And we realized that it's always going to come from something that looks like this. X squared is going to be x and x. So that's already figured out. I just got to figure out the numbers at the end. And in the process, this number times x will combine to be the middle. And then this times whatever the hell that is will multiply to be this. So now I'm working backwards. What would have been there to make both of these things work? And of course, what is it? What two numbers?
6 and 5.
6 and 5. Or 5 and 6. However you like to say those two numbers. Cool. So we did a decent amount of those. Gets a little bit more freaky when negatives get thrown in there. Thrown in there. Negatives get thrown in there. Let's see. Yeah, let's do that. Yeah. Well, it's got to be true about the two numbers. They have to multiply be a negative big-ass number, right? Which means they have to be what kind of signs?
Negative, positive.
Different signs. So they have to subtract to be -1. So they have to be 1 apart. That's why I teach it. You just start 10 and 11. Are they 1 apart? Yes. So it does check off one requirement. What is 10 times 11? It ain't 100. Okay. Is it too small? Yes, 110. All right, go up. All right, 11 and 12. What's 11 times 12? 132. I like it. What's 12 times 12?
144.
Take a 12 away from that. 132. That must be 11 12s. If 12 12s is 144, 11 12s is 1 less 12. Anyway, or use a calculator. Which one's going to be negative?
12.
Why 12?
It's bigger numbers.
Yeah, to make it come out negative in the end. You got to make the bigger one negative, right? So then what's the answer?
X plus 11. X minus 12.
Or x minus 12, x plus 11. As long as the 12 is negative and the 11 is positive, you can put them in whatever order you want to. You guys doing all right? Now this is bigger than you realize. So much of math is built off of the idea of factoring. And you know that. What's almost the first thing you do with numbers when you learn to add and subtract? You start to break them up, making prime number trees. What I call the DNA of the number, right? Like 8 is 2 times 2, that's its DNA. If you put 2 times 2 times 2 together, you get 8. You don't get anything else. You don't get a giraffe, you get 8. Right? It's not the right DNA for the giraffe. I like it. Somebody out there is like, giraffe. Not really listening, just hearing the giraffe. Okay, so, real quick, before I get too far, we have this kind of stuff, which at this point needs to be pretty simple. Oh, I got you. Right? What form of factoring is this? It's kind of a trick question in a way, but what form is it?
Distribution.
Yes, all right, undistributed, GCF. And the reason I say it's a little bit of a trick question is because everything is GCF at first. You've got to rule it out. Make sure you can't take anything out and then start to do something else. This is purely GCF. It's just a bunch of numbers and letters just jammed all. This is totally GCF. So how do I do this?
Take out
Take out
4.
4,
Yeah.
3, and 10. I like it. So 4.
X, Y.
1x, I like it.
Y.
1 Y.
1 Y.
1y, you can only give 1. So it's just like what I said, it's sort of like the fair taxman. I'm not going to take more than you got, but I will take everything you got. Okay, so this guy's got a 1y, he's got 3, he can totally get 3, but I only take 1y from everybody because it wouldn't be fair to take more from him. So you basically take out the smallest power on the variable that you see. And then you write what's left. And this seems very small, but I always try to write this over a little bit so I can see this term and that term. The minute people write something here, they kind of like forget this guy entirely. So what's left here?
4. X.
3.
3
X. I like it. No more Y's. Good.
minus 10
10.
Y squared.
Yeah, no more X's.
squared.
Square. I like it. And how I know I'm done? 3 and 10 ain't got nothing common. He ain't got no Y's. He ain't got no X's. Jeff has got a little bit of a grasp on the English language. I like it. All right, let's go to the thing we haven't done yet. That's what I want to do. Makes sense. So I don't know. I don't think we talked about this other side of this at all, did we? Or did we start it?
With the substitute, we did it.
Yeah? Okay. Oh, yeah. Oh,
But she did it differently than you.
Okay, I understand. Well, I hadn't done this yet at all, so
Well,
you don't know how I do these.
She kind of had her own
Oh yeah, we all do. We're weird.
She was using the X.
yeah.
Yeah, okay, that's fine. It's incredible to me. The X, all it does Remember the whole add,
I
multiply?
think it's just like a visual, so you can kind
I
of see.
just don't understand. It's sort of like putting a magnet on the back of your neck and it keeps you from being seasick. Like, if it works for you, fantastic. I don't give a shit. Has nothing to do with science or anything else. Do it. Doesn't work for me, I can tell you that. Because my nickname used to be Jetty because that's about where I'd lose it. So you should have done the motivation. Hope to God, and I sort of did this a little bit with you guys before. I told you how the first numbers are going to mess with the middle numbers. I don't know if you guys remember this. Maybe. But here's the steps. Here's how you do a problem like this first one, 3x squared. This is, yes, just that one. You can have it. So the trick is, since the first numbers, in fact, what do I know about this? It can't be x and x, can it? In this case, it's got to be 3x and x. Right? And I'm not looking for two numbers that multiply to be 8 and add to be 10. I'm not. I can't be because this stupid thing's going to mess all that up. So this is very often called the AC method. Why the shit? It has nothing to do with air conditioning. It's because ax squared plus bx plus c is the general way to represent that. And what's the first step in this process? This number times this number. You've got to take the 3 into account. And to be really honest, of course I don't have a problem like this. This one we did earlier, we did that. What's the number here?
1.
So 1 times 30 is 30. Find factors of 30. That had to be 11. So it's not really different. The difference comes in this step here. So 3 times 8 is 24. What multiplies 24 adds to be 10.
6 and 4.
6 and 4. But you can't just jump to the answer because that's got a factor of 3 all mixed up in it. So what is the way to get to the right answer correctly for Mr. Waller? There is something you can do here where you divide by shit, and it's complete bullshit. If I ever see somebody using, there's a method called bottoms up. So if you ever go for tutoring for factoring, say, my teacher is a good teacher, and he doesn't want you showing me bottoms up. Because number one, it sounds like, you don't want that coming at you from out of nowhere. But I don't know why it's called bottoms up. It's either drinking or something, who knows. Here's the correct way to do this. If I can make this into 4 terms, I can then do one of the easiest forms of factoring, which is grouping. Now, stay with me. This is really kind of cool. How many ways can I make this into 4 terms? I can break 10x into 5x and 5x, 11x and minus x, 200x and negative 190x. Holy shit, there's like an infinite number of things. But what are the only 2 numbers that will make the grouping work? The ones we just found. So if I break 10x up into 6x and 4x, does it have to be 6 first? No. Now grouping will work. So this is what's called, it was called this when I was taught it, so this is not a name I made up. I call it the surefire method. Because if it will factor, this method, surefire, will get you there. I was born in Georgia, but I didn't take algebra in Georgia. So I can't say what was that. So how do I group this thing? What does that mean? How many terms are there?
Pull out the GCF.
Yeah, for each group. So what comes out of these?
3x.
3x.
X plus 2.
So what's got to be here? X plus 2 has to be here. Now I know this is an easy one, but in general, if you get this first part done, it's a clue. Got a clue. What comes out of here to make this an X?
4.
4. And of course 4 coming out of 8 makes it frickin' 2. Thank God. That means I'm on the right track. Yes, sir.
And you said you don't have to write them in any specific order.
Yeah, in the middle.
The middle ones, but the 6 and 3 just go together better, right? Is that why you wrote them like that, or?
No. Just because somebody happened to say 6 first when I asked.
Okay.
Yeah.
But
So we'll do it both ways.
Okay.
So what happens at the end here, I can take out an X plus 2. And what's left?
3x plus 4.
Now, if I would have written this the other way, with 4x and 6x instead, what comes out of these two? Just x. What comes out of these two? Well, how do I make this become 3? I take out a 2. And then I end up at the same place, right? These are the same thing. Just here, the 3x and the 4 are on the outside. Here, they're on the inside. It is on some level kind of nifty. I know for math, but for math, that's pretty nifty. Hopefully it's not just me. Could be. I'm used to that. Okay. Let's do another one. I'm going to do one that's not on the sheet. I don't know if it's on the sheet. I lost my sheet. Let's see if you can tease out what I'm doing to make this something that works. All right, this is going to be scary, Jeff. That's all right, dude. You can make it. Let's see. Ooh, this is going to be gross. Oh, this is going to be so gross. I love it. Yeah, that should work. Let's find out if Jeff made one that works. So like that matrix debacle. All right. The very first step is GCF. Never forget that. Because if an 8 comes out, screw the AC method. I can just get that stupid thing out the way. Can I take it out? Ah, shit. Can I take anything out? Shit. If you are able to take something out, it makes all the numbers smaller, which is always nice to work with smaller numbers. Nothing comes out. Thanks, Mr. Waller. So what do?
8 times negative 15.
8 times negative 15. What's 8 times negative 15?
Negative 120.
Negative 120. I liked it. Technological assistance, but it's fine. And what do I need?
Something that adds to negative 19.
Something that adds to negative 19. 2 numbers. And then also multiply to be negative 120. There are so many factors of 120. You with me? There's too many. So again, this is where I would start with this. They have to be opposite signs, right? Now, as you really stay with me, yes, you have to think a little bit. But if you think a little bit, you can make a list to check and get there quicker. They have to be different signs, so they basically have to subtract to be 19. So let me get us started. 22 and 3, do they subtract to be 19? Yes, if the 22 is negative, they would add to be negative 19. But what's 22 times 3? 66. Too small, so I'm going to make my numbers bigger. It's like Price is Right, right? So then maybe let's do 24 and what? What would make 19? 5. And what's 24 times 5?
Negative 120.
Yeah, negative 120. Kick ass. No, yeah, you're right. It's kind of like whenever there's a demonstration, it works perfectly. It's like I'm selling you a vacuum cleaner, and when I leave, it doesn't work worse shit. That basically summarizes your homework experience. I'm sure. It worked. It sucked up the dirt in the classroom. You shit at my house. All right. Sorry. It's horrible when the teacher is a distraction. I'm sorry. So, the steps here are, the first number's not a 1. It won't come out. Nothing will come out. Shit. I have to multiply these. Why does that make sense? Because the factors of 8 are going to get mixed up with the factors of 15 doing it forward. So I've got to consider that going backwards. Are you guys? All right. So I multiply that. And then I still find 2 numbers that multiply to be that new number and add to be that middle number. And that's what we just did. We got those. This. So what do I do next?
Split them up into groups.
Yes, and here's where I would say, you still can put them whatever order you want to, but you see how one's negative, one's positive. I would put the negative one first, and I'll show you why. So I'm going to break up negative 19 like this. Do you see how I'm not forgetting the x? Why would this not make any damn sense? What's negative 24 plus 5? It ain't negative 19x. So when you get those numbers, you're just finding coefficients. And then I can group. It's when there's a minus here that people make a crazy mistake, a negative mistake on the grouping. So if you have a choice, I'm going to put the frickin' positive thing in the middle. Shit, yeah. Will it still work the other way? Of course it will. So what comes out of these two?
Negative, 8x.
8x. X minus 3, I love it.
And then 5.
5.
X minus 3.
So then I get 8x plus 5, x minus 3, or the other way around, however you like to write it. Hopefully you understand that the 5 has to be with the 8x. If you put the 5 over there instead and the 3 there, it's not going to work. You're not going to get the right combination of middle shit. Maybe. Okay. So that is called surefire method. Sometimes it's called master product. And yeah, the step I'm skipping with the x, if you did like the x, I don't even remember. I think you put negative 120 here,
Put the multiple on top.
and then you would put the 19 here.
Just division.
But does it change the work we did? No. But I'm surprised there are people that are like, I can't do it. And then they write this, oh, I can do it. Like, whatever makes it work. I actually don't care anymore. If it makes it easier for you and it makes it work, fantastic. As long as you're not doing, remember this, the bottoms up method. So if you do get tutoring, say, don't show me the bottoms up method. You got Jeff Waller? Yeah. Oh, damn it. And then they have to remember the right way to do it. It's crazy. Sorry. What's that? Now you're all like, I want to see this shit. I'll tell you this. If you do want to use that method, if you see it and want to use it, you have to explain to me why it works. If you explain to me why it works, I'll let you use it. I've never had anybody able to do that. So here's the next thing. So now we know what to do. 4 terms. 4 or more terms. What do I do? Grouping. I love it. 3 terms. It could either be the x squared plus bx plus c thing, right? Where you get factors of c that add to b. Is that cool? Or it could be the one we just did. AC method, master product, whatever the hell you want to call it. Master product always sounded to me like something from Tron. The master product. So all we got left, and of course GCF really is the first dude. He's always there, just in the background, just like, try me first. So today, we're going to focus now on 2 terms. What do we do when there's just 2 terms? And there's 2 main things. The first thing is kind of funny. Let me ask you this. Just so you know that we're not doing the new stuff yet. How do you factor this guy? What are you thinking about when you see that?
3 times 3.
Yeah, when multiplying 9 adds to be 6, obviously it's 3 times 3. So you can actually write it like this. Is that cool? Is that right? That's old news. So now watch how this works exactly the same way. What's kind of missing in that one I just wrote?
The middle term.
What's it mean if the middle term is missing? That means the middle terms should have killed each other, right? So the middle terms have to be opposite signs, which makes sense, because if I have 2 opposite sign numbers, they multiply to be negative. So let me write this a different way. That's really what it is, right? So what 2 numbers multiply to be negative 9 and add to be 0? Negative 3 and 3, right? So watch how this works. Don't ever write it like that. Just realize that's what it is. But now I got a shortcut. Now I have a shortcut to do these. How do I make x squared? X times x. How do I make 9? 3 times 3. How do I make negative? Negative times positive. Done. This is called a difference of squares, bless you, because math people are master namers. We just love the name. Right. There's a difference of squared things. Call it difference of squares. So it's called difference, not difference. Difference of squares, because it's the difference of two things that are squared. So it almost makes too much sense. I make x squared, x and x. I mean, not 3 and 3. Minus plus, why do I make it minus plus? So the middle term does cancel, and this becomes minus. Let's do another one. Stay with me. So what about y squared minus 81? Let's do another easy one.
Y plus 91.
Yeah, y. 9. Minus plus, done, thank you, move on. So a difference of squares is a thank whatever your favorite deity is. Thank whatever, fill it in. For me, it's the god of coffee. Thank you, god of coffee. So watch here. I'm gonna do something I do sometimes. I'm gonna take a huge step. It's gonna feel like I'm taking a crazy big step, and it's just too bad for you. I like it already. This is yummy. Okay. How many terms are there?
6.
No. How many terms are there?
2.
2. 1, 2. They're always separated by plus and minus. Right? So there are 2 terms. Is there a GCF?
No.
Hell no. Can you cut everything in half? Which is really what a square is. Why is 9 something square? Because I can cut it in half. 3 times 3. In half multiplicatively. Is that cool? So I can identify this as a difference of squares. I don't care how ugly it looks. It has to be easy. You just cut everything in frickin' half. I gotta make it a little bit bigger. Cut it in half. What do you get?
25W5.
Cut 25 in half. 5. W10 would be W5.
And then Z24.
Z24. Alright? I might have more with me even. Minus, and the other one's going to be a plus.
7.
7.
8. V10.
And then you write all the same shit, just the only difference is plus. Alright, let's try it. You ready? We've designed this to come out correctly. Because what is this times this? Where they're both half of this dude, so this times this is this dude. You guys with me? 5 times 5 is 25. W5, W5, W10. 21, 24 is 48. Minus a bunch of bullshit plus the same bullshit. Bullshit gone. Right? I really want you to see how that looks easier than this. But it isn't easy, it's just a little less to write. That's it. That's it. They are the equal easiness. I cut that in half, and I cut that in half, minus plus. Cut that in half. Now, just to show you, obviously that was constructed, right? What if I do this? How do I do that?
5Y.
Careful. See, this is the step where everything I've done so far I've put together so it will work right. But then I'm trying to remind you guys that not everything is factorable. Right? Why can't I do this? There's 2 terms. I can cut some of them in half, but can I cut everything in half? No, so screw it. Prime.
It's because of the W.
Yes, I have not the right number of W's. I can't cut that in half nicely. We try to use whole numbers and whole number exponents when we do this. So if I would have...
So even if all the numbers cut in half evenly except 1, it doesn't work?
It's totally dead. Totally. And completely. It's sort of like cut 8 into 3 parts. What is it? 2, 2, 2. What's 2 times 2 times 3 is 12, right? 2 times 2 times, so that's 2 times 2 times 3. I'm trying to make a point here. What am I trying to do? This I can cube root. This I can't, even though 2 of the parts match. So I really want you. All I need is one stupid thing to not flow, and it kills the whole thing. Right? If I said write 3 numbers that multiply 12, you can't. I got 2 of them, not 3. So here I got one piece of this that doesn't follow. I can't break it all up. But if I would have written it like this instead, of course that'll work now. How do you work it?
5y
5y.
minus 3w squared
Yep, and then you write the same thing
plus
with the plus. You have to understand how difference of squares is a thank God problem, or I think, like I said, whatever you attribute good things to. Can't like it. I personally am not religious, but that's why I substitute God a coffee. Okay. Let me let you try one more. So you guys can handle this. It's exactly the same problem I have on this hand. I don't want to do that.
Two x.
Yeah, what do you always have to think first? I mean, you look at that. Can you cut any of that shit in half correctly? No. Right? But what saves you is what you skipped if you're thinking that way already. You always think GCF first. Always. So yeah, what can come out?
2x. X
4
squared.
Yeah, 4x squared. And the x is gone. What's this?
The difference of.
Difference of squares. So now GCF sometimes is the first step. Because once you get the stupid 2x out the way, you can see it's trying to be a difference of squares. So it's just buried under a 2x. So this dude comes for the ride. He's done, but he comes for the ride. And how do I break this guy? 2x
Minus 5.
minus 5?
So x
2x plus 5. Kicking the ass in. That's too funny. I know little Germany's about 4 foot. All right. So here's the last thing. What time is it?
11:50.
Thank you. This is the last thing for today. And then I'm going to give you guys something we'll finish working on next time. This one's going to take a little bit. All right. So we've got, let me do a real quick little easy example. So this will factor like this. Right? That's all nice and good. That's fantastic. So I got 2 x's, so I put 1 of each. I got 2 3's, so I put 1 of each. Plus minus to make the shit I don't want cancel. I love it, right? Is that cool? Just basic summary of what we just talked about. Now, unfortunately, the way you might think this would work, how does this relate to this? How do these kind of relate to each other?
One's a square, one's a cube.
Yeah, this one's got everything cubed, right? What's 27?
Something.
Break it into 3 parts.
3 times
3, 3, 3. You with me? Now, I understand. In fact, promise me this. You will not write what I'm about to write. Just don't even write it. I get people think the answer is this. Something like that, or some combination of that. You can see, and I love the look on some of your faces when really some of you guys are like, yeah, I thought it was going to be that. You can see why somebody might think this is true, but if you multiply this shit out, in fact, let's multiply this shit out. Here, I'll just do it real quick. Let's see. Do you get this? No, you get extra shit. It didn't kill correctly in the middle. There was no pluses in there. And then if you throw some pluses in there, it doesn't save you. It doesn't cancel things correctly. So, has anybody ever seen Pulp Fiction? Okay, I'm going to somehow work one of the most infamous scenes from Pulp Fiction into this idea. Right? Whenever you see this guy, here's how this is going to work. I want a little dude and a big dude. This is the only way these things can work correctly, so that they cancel the shit you don't want. On one level, hopefully this kind of makes sense. Instead of doing one of each in each piece, I'm going to do 1 and 2. So for example, if I put 1x here and 2x's there, doesn't that make x cubed? So far, so good. So I'm going to put 1 of each in the little dude, because it's a little dude. You can only take 1 of each. And then 2 of each in the big ass dude, right? So here's another way to kind of, this is x times x times x. So I put 1x here, and the other 2x's there. What's 27? 3 times 3 times 3. So I put 1 3 here, and the other 2 3's there. So now somebody might say, well, shit, Jeff, stop right there. If you do this, same sign, don't I get, there's my x cubed, right? There's my x cubed. There's my minus 27, right? But have I multiplied that out correctly? No. I forgot about minus 3x squared. Do I want that? No, it's not in the problem. And I also get plus 9 frickin' x. So who do I call when I have a mess that I need cleaned up? The wolf. So the middle term, even if you've never seen Pulp Fiction, the purpose of the middle term, the reason I have room here, the purpose of this guy is to clean up this extra shit you don't want. What's the purpose of plus minus? Clean up the shit in the middle you don't want, right? They cancel so you get no middle term, which is good because there's no middle term here. You guys kind of with me? Here's a little more in your face. Now watch this, watch this. Okay. I'm going to put a term here. Right, and I'll tell you right now, it's going to be plus. It's always the opposite sign. Why does that make sense? It's the cleanup dude. It's got to be the opposite sign so it can clean up. Stay with me now. This is kind of cool. Let me see if you guys can get this just directly. If I wanted to kill the negative 3x squared, do you see how this is going to be x times this? What would I put there to make positive 3x squared? Well, x times what? Yeah, 3x. And what would I put here to make negative 9x? Well, I get negative 9x already, don't I? And where did 3 and x come from? 3 and x. So whatever is in the little dude, you multiply to make the middle piece. It's crazy. So 1 of each, 2 of each, product in the middle. Closest I'll come to singing a song of math. Do-do-do-do-do.
So
We'll do some more, trust me, because this gets a little weird.
but you're saying what's in the middle, basically, what's in the little term should cancel what's in the middle term right there.
Yes, I see what you mean.
'Cause it's
Yes,
a
it'll be a
negative
different
3x.
sign. Opposite
Yeah.
sign, this times this.
Yeah.
Always.
And that's a positive 3x.
Yes.
Yes.
So let's do another one. I want you to really see that. So how many of each everything do I have? 3. So what did I do? 1x, the other 2. 1, 3, the other 2 3s. This is the only thing that really kind of doesn't follow the pattern. But you can see now, what do I pick up when I do that? I pick up minus 9x, and I pick up plus 3x squared. So I am left with that. So that does multiply me out to come out to be that. Let's do another one. This is the one that everybody hates because it's the one you have to just pure memorize. The other ones you can kind of like sink your teeth into and feel like you're doing something here. Ugh. I understand, but it's also freaking cool. By the way, Let me show you. I've never shown in class this, so feel honored or feel scared. I don't know. Remember I told you that some people try to assume maybe it's this? Right? Maybe don't even write this down because this is experimental. I've always wanted to try to work this in, and I've been working with it. It's not quite there yet, but I want to show you. If I multiply this out, I get this. How far off is it from what it's supposed to be? Do you guys see the only difference is this? So that's a guess. That's a good guess, but it's completely wrong. Because if you multiply this shit out, you're going to get a bunch of middle terms, right? And it's because that guy is always twice as much as it's supposed to be for it to work. It's kind of neat. I haven't really put it together yet to be a teaching method yet, but I saw that a long time ago and I wondered, there's got to be some way to show that. Anyway, some of you guys are like, dude, please, dear God, don't show me anymore. So let's try another one. Let's see, what about 8w cubed plus 27? Let's put a letter on you too. Ha.
Is that Wolf and Marvin?
Yes. There you go. No, I can't get that South Park out of my head. No, stop it, Marvin. All right, so one of the very first things you do when you see a cubes, how do I identify this as a cubes? Don't just look at the powers of 3. There's no GCF and there's only 2 terms. So when there's 2 terms, it's either squares or cubes. And this is very obviously not just because of 3, but because 8 is 2 cubed. 27, of course, is 3 cubed. LA. So 2 things you want to do. First thing is put a little dude and a big dude down. But also break these up. 8w cubed is 2w times 2w times 2w. Is that cool? 27m cubed is 3m times 3m times 3m. And now it's just constructing stuff. What goes into the little dude?
W plus
2w. Plus, I like it. 3m. So one of each thing goes into the little dude, which means what goes here, 4w squared. What goes at the end,
9 m squared.
now that all of that